x to the 12th divided by x to the 7th. Again, you're subtracting the exponents. So just do 12 minus 7, which is
5.
X to the 5th. There you go. Nine to the 7th. Question?
What is that QED thing?
Quo ora demonstrata.
Demonstrate.
So it has been demonstrated. So it has been shown. So it has been proven. It's Latin.
Okay.
All right. 9 to the 7th divided by 9 to the 3rd. So subtract the exponents. That's going to be 9 to the 4th. Now 9 to the 4th can be simplified. 9 times 9 is 81. Times 9 again is 729. Times 9 again is 6,561.
What is it?
6,561. All right. Example 6, a little bit more complicated because now I'm giving you bases that are numbers and bases that are exponents, or variables. So we've got 4 to the 15th, a squared, b to the 8th, over 4 to the 5th, b squared. All right, so let's start with the 4 things. 4 to the 15th and 4 to the 5th. That's 4 to the 10th, good. Now, notice a squared is unmatched. There's nothing I can do with a squared. So I'm just going to leave it alone. B to the 8th and b squared? B to the 6th. All right, now obviously 4 to the 10th can be simplified a little bit. That's 1,048,576. And then you would have a squared b to the 6th. Now, question that was asked in the last hour, and it's a good question. What if a squared would have been down here? Okay? Instead of being up here, what if it was down there? Then, instead of having a squared up here, you keep your fraction bar, and you would just leave a squared all by its lonesome. And it'd be in the denominator. Okay? If the problem was this, if it was this instead. Notice everything's the same, but I moved a squared to the bottom. Right? Since there's nothing up here that I can actually subtract, it would just stay in the bottom by its lonesome. Okay, so it would be all this stuff over a squared. It would be like that. It's a good question. It might come up in the homework. All right, if you can't subtract it, you just leave it where it is. Or if you can't add it, you just leave it where it is. You don't move it. It's a good question. It might come up tonight. All right, put this back, and then we'll go to the last one. Now, last problem here, you're using both properties. Was there a side question? I thought I saw a hand. Sorry. I'm trying to bluff somebody. All right. Y to the 4th times y over y cubed. Y to the 4th times y over y cubed. So you notice we've got a product. The numerator, the top, has got a multiplication problem. And we've got a quotient because it's a fraction thing, so we've got to do both things here. So, let's start with the product. I've got y to the 4th times y. That would be like y to the what, though? This would be like y to the 1st, good. So I put those together, and that's going to make y to the 5th, good. So I've got y to the 5th over y cubed. Now it's a division problem. Now you can subtract y to the 2nd. Good. There you go.